Alright, welcome again in another tutorial of the topic integration. So in the previous tutorial, we said that an integral, the other definition for an integral is just the limit of a sum. Okay, so you can watch that tutorial. It's called integral as a sum. It's a previous tutorial. So this is what we said, okay? That definition ya integral, okay, integration is just a limit of a sum. Sasa kwenye zile tutorial za zamani zaidi tulisema kwamba integration, okay, tutorial ya kwanza ile ya hii playlist ya integration, tulisema kwamba integration is the inverse of differentiation. So kumbe zipo definition mbili za integration, okay? Kuna hii definition ya integration is the limit of a sum hii, na kuna hii definition ya integration is the inverse of differentiation. Sasa hizi definition mbili mtu anaweza kusema kama hazina mahusiano hivi. Mtu anaweza kusema kwamba hizi definition mbili hazina mahusiano, yani kwamba mtu aliyesemaga integration is the limit of a sum alikuwa amezaliwa kisiwa kingine kabisa, na mtu aliyesema integration is the inverse of differentiation alikuwa ametokea kisiwa kingine, na watu wawili walikuwa wafahamiani, na ijapokuwa alama yao ya integration ni ile ile, ila integration walizokuwa wanazizungumza ni vitu viwili tofauti. Kwa hiyo mtu unaweza ukasema kama hivyo, unaweza ukasema kwamba hizi definition mbili za integration hazina mahusiano. Lakini sasa in this tutorial what we are going to do is to show the relationship between these two definitions and to show that how they are connected, okay? Yaani nitakachokifanya sasa hivi ni kuonyesha kwamba integration as a limit of a sum na integration as the inverse of differentiation is just the same integration, okay? It's just the same, okay? Nikisema limit of a sum ni hiyo inverse of differentiation. Nikisema inverse of differentiation ni hiyo limit of a sum, okay? So that's what we are going to do in this tutorial. Now, in order to establish this relationship, okay, between these two definitions of integration, first recall in the previous tutorial tulitafuta kwa tunajaribu kutafuta the area under this curve. This curve y is equal to psi x, okay? Tukua tuna hii curve, hii ni curve y sasa psi x, ambapo tukua tuna look for the area, tukua tunatafuta the area ya ili eneo ili eneo AUVB. Tukua tunatafuta area hii eneo ambapo tulitumia method of a limit of a sum, ambapo tuligawanya ile eneo kwenye rectangles nyingi zenye equal width, kama hii rectangle PNMR. So now kwenye kusolve kwetu pale, okay, tulifika mahala tukasema y delta x is less than delta ax, okay? So I'm not going to start again, just remember that tutorial, okay? Ambapo y delta x now was the area of this rectangle, okay? This PNMR. So the area of this rectangle, where the area of rectangle PNMR ndio ilikuwa ni y times delta x. Okay, and hii delta ax ilikuwa ni the area of the region PNMQ, ndio ilikuwa hii delta ax. Okay, delta a of x, sema hivyo. So I mean hii kwa sababu hii point P ilikuwa coordinates zake zilikuwa ni x, y. Point N, hii ni point P hapa, okay? Point N coordinates zake ilikuwa ni x, 0. Point M, hiyo nimesema ilikuwa N. Point M coordinates zake ilikuwa ni x plus delta x. Kwa hiyo tukaona kwamba length Pn, okay, ni y, alafu width hapa ni delta x. Kwa hiyo y times delta x ndio ikawa the area of this rectangle PNMR. Lakini the area of the region PNMQ, okay, it's not a rectangle region, ndo ilikuwa ile delta ax tulisema. So the area of the region PNMQ is greater than the area of the rectangle PNMR kwa sababu ya hili eneo hapa linalozidi hili. Okay, but look at this new diagram sasa ambayo nimeiweka hapa. There is another rectangle now. The rectangle the rectangle SNMQ, okay? So notice, okay, see the rectangle SNMQ. Okay, what is its area now? The area of rectangle. Here we discussed in the previous tutorial, but I have drawn it now. SNMQ. We have another rectangle now. It's the rectangle SNMQ. Hii rectangle kubwa. So you can see hii rectangle ni kubwa kuliko hii rectangle PNMR, lakini pia ni kubwa kuliko region PNMQ. Okay, so the point Q now, the point M, by the way, the point M was x plus delta x, 0, okay? The point Q now is x plus delta x, y plus delta y. So width inabaki ile ile delta x, lakini length inakuwa ni hii sasa, y plus delta y ya hii rectangle SNMQ, okay? Yaani urefu kutoka hapa mpaka chini utakuwa ni y plus delta y, kwa sababu tulisema hiki eneo hiki PS ni delta y. So it means area sasa ya rectangle SNMQ itakuwa ni y times delta y plus y plus delta y times delta x, length times width. So the area of this new rectangle here, SNMQ, is equal to y plus delta y length times delta x. Okay. So see, here rectangle SNMQ is greater, okay? Greater kuliko huyu. Area of the region PNMQ, na hii ni greater kuliko huyu. Area of the rectangle PNMR, kama hivi. You see, rectangle PNMR, hii ambayo nimeshade hii, ni ndogo kuliko region, maana uongeza na hii curve. Okay? Lakini hii region ni ndogo kuliko hii rectangle mpya sasa SNMQ. So this is what we have now. Okay, we can see that the area of rectangle PNMR is less than the area of region PNMQ, is also less than the area of rectangle SN MQ. So area of rectangle huyu tumesema ni y delta x, area region tumesema ni delta a of x, where a of x was the area under the curve. Remember, okay, remember kitu fulani. Remember kwamba ax ilikuwa ni area ya CONP, okay? Kwa hiyo area ya COMQ sasa ndio ilikuwa ni a of x. Just watch the previous story and everything becomes easier. Hivi, okay? So hii ndo ile eneo liloongezeka pale. That's what we said. So this now is also less than the area of this rectangle. Kwa hiyo ni hivi sasa. Times delta x, this one. Okay? So let me just remind you about this a of x and delta a of x. So a of x, remember, equals the area of CO and P, okay? So tulivyoongeza na P N M Q, ikawa a of x plus delta a of x, okay? So area of CO and P ndo a of x, area of CO and Q ni a of x plus delta a of x. So just remind you about that. So we are here now. We are here that y times delta x is less than delta of a of x, which is also less than y plus delta y over, times delta x. So when we divide by delta x hapa, kila mahali, okay, we can do that. We're going to remain y is less than delta a of x over delta x less than y plus delta y. So tunafika hapa. Sasa tukaja tukasema kwamba width ikipungua, okay, rectangle hizi zinakuwa nyingi. Okay? Na hiki kisehemu hiki kilichozidi hiki PRQ hiki, PRQ kinazidi kuwa kidogo. Manake QR yenyewe, QR ambayo ni delta y, okay? PS. QR is equal to PS, which is delta y, becomes small, okay? So, this is what I want to say here. I want to say as delta x now becomes small, the width becomes small, then delta y also what? Becomes small. Okay, so manake nini? Manake sasa the limiting value ya huyu hapa as delta x approaches 0, okay? So delta x ikiwa ndogo, delta y pia ina approach 0. So delta y ki approach 0, manake y plus 0 is just y plus 0.000 something is just y, yani kinachoongezeka ni negligible. So it becomes like this, okay? It becomes like this. Okay, kwamba delta x width ikipungua na kile region kinapungua, kwa hiyo delta y inakuwa ndogo sana, almost negligible. Okay, remember we say that. So we are here now. We say y is less than y as delta x approaches 0. So here we have this one over this one. So on a level outward, how can y be less than this and at the same time y is greater than this? So this just means, okay, this means kwamba y sasa ndo inakuwa sana limit. Ukiona situation kama hii, maana tunaondoa tena hiyo inakuwa, yani y iko mbele na nyuma, maana ni almost equal to, okay, it's just equal to, so as it approaches 0 like this, okay? So we are here now. Okay, kwa hiyo as delta x approaches 0, the limiting value of delta of a of x over delta x is y. Sasa hii hapa, remember ile topic ya differentiation. Technically hii hapa tuliyoandika hii ni definition ya nini? ya differentiations, okay? This is just this, okay? Angalia video inaitwa gradient of a curve kwenye playlist ya differentiation. Angalia au video inaitwa incremental notation kwenye video ya differentiation. So this sasa is just a dA dx, okay? This is just dA dx, okay? So kumbe y is equal to the derivative of a with respect to nini? To x, okay? Sasa kama y is equal to the derivative of a with respect to x, then a of x, okay, is just the infinite integral p, okay? So kumbe the area a of x is also the integration. Sasa this integration is what? Is the inverse of differentiation, okay? So naona hapa ni differentiate nika. Sasa you can see nimetumia concept ya nini? Ya limit of a sum. Nimefika kwenye nini? Kwenye inverse of differentiation. So manake integration ya kwa inverse of differentiation na integration kwa limit of a sum ni njia ile ile. One. Second, unaweza ukatumia zile method za integration za inverse of differentiation, okay? Kutafuta area under a curve. As a matter of fact, tunatumia hizi zaidi kuliko we don't use ile method ya limit of a sum kwa sababu kama unavyoona ni ndefu. Kwanza kugawanya ma rectangle pale, kutengeneza formula, kuapply limit, mpaka kuja kupata limit ni ngumu. So we don't use this limit of a sum, okay? We use hii concept ya integration as the inverse of differentiation kusolve maswali ya area under a curve. So in the next tutorial tutasolve hayo maswali ya area under a curve. Sasa I want to just add one more thing. Okay? A of x tumesema hapo ni sasa na huyu. Si ndio eh? Lakini remember A of x nisema ilikuwa ni area ya region gani? Of CO and P, okay? Sasa sisi tulikuwa tunataka area of AU VB, okay? Sasa area of AU VB manake ni siona AU VB, okay? Hii ni CO and P, CO and P, okay? AU VB manake uchukue A, kwa hiyo CO and P kwa sababu tunasema n ni x, kwa hiyo ni A of x. Kwa hiyo kupata AU VB manake uchukue area ya COUA, I mean uchukue area ya COVB umaana zina COUA. That's what we're going to do. You're going to take the area of, kupata area of AUVB, you're going to take the area of COVB minus area of COUA. Sasa kama area ya CO and P ni A of x, maana hapa itakuwa ni A of B kwa sababu x pale ni B minus A of A. So area of AUVB now itakuwa sasa na area. Sasa hii you see ndo tuna introduce to limit hivi, okay? This is how you interpret this. Introduce the limit from A to B. Kwa hiyo mkubwa anakaa juu, mdogo anakaa chini. We shall solve these questions. So hii sasa you just solve it by the method of nini? Okay, solve by the methods of inverse of differentiations. So I think we have seen now the relationship between these two definitions, okay? Yeah. So hizi A na B sikuziweka hapa, but you can see kwa sababu this was CO and P where the value of x is unknown. So hapa x is known, so we have the limits of integration. We introduce the limit, okay? B mpaka A. Like that. So now let me show you something, okay? I have told you that the integration, the definition of integration as the inverse of differentiation is just the same integration to define as the limit of a sum. So I want to prove it now, okay? Okay, remember kwenye tutorial inaitwa calculation of an area as the limit of a sum, okay? Remember tulitafuta area ya, this one was O A, whatever, just put any letters, okay? I'm not going to remember those letters. Or A, B, C, okay? Kama hivi. Tutafuta area ya hiyo trapezium kwa kutumia method of limit of a sum, okay? Kwenye ile tutorial ya calculation of an area as a limit of a sum. Tukapata ni ngapi? Ni 60. So now let us find this one kwa kutumia method ya inverse, area hii kwa kutumia method ya inverse of differentiation. So kwa kutumia method ya inverse of differentiation, area of hii trapezium OABC, okay, area of this trapezium ni trapezium OABC, okay, itakuwa ni sawasawa, tumesema na nini, ni integrate y dx, afu hizi ni limit. So hapa a itakuwa ni, kwa sababu hii inaanzia at x equals to 0 mpaka x equals to 10, so a is equal to 0 alafu b is equal to 10, okay, and then y now maana si hii sasa, hii sio curve, ni straight line, okay, y ni 1 plus x, okay, so area yetu sasa is just gonna be in integrate 0 mpaka 10 1 plus x dx, okay, let's do that one. So our area there is just gonna be equal to, I mean, from 10 x is equal to 0 1 plus x dx. So this is just the same as you say 0 10, natumia sasa method ya inverse of differentiation, dx plus 0 10 x dx, okay, kwa sababu dx kama nimeingiza ndani, so it's become dx plus x dx, eh? Kwa hiyo hii sasa nimeifanya imekuwa hivi, okay? So I can do this, okay, so nikishafika hapa sasa, ukiintegrate dx you get x, we have done this, okay. Sasa ukiwa na limits of integration, so this is the first time tuna solve integration in a limits of integration, but usiweke constant plus c, bali weka hizi limit kama hivi, okay, so you get x, and then here what do you get? Hapo c ni, so remember this x n dx, ukiintegrate tulisema unapata x hivi, okay, plus c, so hapa itakuwa ni x, n ni moja maana yake hapa, so 1 plus 1 is 2 over 2, so aweki c nimesema kwa sababu kuna limit, unaweka 0 to nini, to 10. So hizi limit naziingizaje? Tunaona hapa kuna x, so itakuwa ni naweka kwenye x naweka 10, naweka minus, afu kwenye x naweka 0, jumlisha. So here kwenye x naweka 10 again, naingiza 10 na minus, kwenye x naweka 0 kama hivyo, okay. So what do I get here? 10 minus 0 is 10. Here I get 100 over 2, okay, minus 0 over 2. So this now becomes the area. The area now becomes 10 plus 100 over 2. So it's just 10 plus 50. So the area now of trapezium kwa kutumia method ya integration as inverse of differentiation, napata 10 plus 50 is 60. So this you can see nikitumia method ya integration as inverse of differentiation, napata jibu lile lile kama nilivyotumia integration as a limit of a sum, okay. So it's just to prove that integration as inverse of differentiation and integration as a limit of a sum is just the same thing, okay. So kutafuta area under any graph, area of any graph, I will just use the normal methods of integration zile tulizosoma, integrating the simple polynomial expression na kadhalika. So I hope you have seen the relationship between these two definitions. I hope you have understood this tutorial. Let me just say see you in the next tutorial.